And you see the chapter 12 screen?
Yeah.
Okay, Sean, thank you. All right, so let me begin. As I mentioned, we are going to go over chapter 12 today, perfect competition and the supply curve. And I have released the practice test with questions from chapter 3, 6, 9, and 10. There'll be 10 questions from each, 40 questions. I have no limit on the time and no limit on the number of tries that you wish. Every time you try, you will get a different set of questions. So they'll give you an ability to cover all the material in these chapters. The test will be scheduled for next week, which will be in the second, we'll start at 8:30 sharp, and I'll end the lecture at 9:30, and then from 9:30 to 11:30, you'll have a full 2 hours for the test. Test one. Any questions regarding that before we begin?
So, Professor, good morning. Good morning, Professor.
Yes, good morning. How are you?
All right. So, the question and review paper you will be posted when?
A review I'm going to do today.
Oh, okay. Okay. All right.
Yes, but the practice test is already opened and it should be available to you until like 8 a.m. next Friday.
Okay.
And at 8:30, we'll start the actual test.
Okay. So 2 hour is going to be test and 40 questions, correct?
Yes.
Okay. It's similar to review, right?
I will be doing the review today. You'll see what I'm trying to do. I am just giving you those chapters.
Okay.
And we'll take 10 questions from each of those chapters. Every time you try, you get 10 questions. And as I said, there is no limit on the time.
Okay.
And no limit on the number of attempts.
Okay. All right. Thank you.
Okay, very good. All right. So today, we're going to talk about perfect competition. We began the class with the understanding of different principles, and one of the definitions that we adopted is what is a market, what is a perfectly competitive market, and we're going to get more specific about what perfect competition means. When economists refer to perfectly competitive markets, we would learn about the characteristics of such a market. Second, we'll be specific about what are the specific factors are there that make a market competitive and distinguish it from others that are not competitive. In a competitive industries, the basic question about economics is, how do people make decisions in those circumstances? If they are in a competitive market, what are the rules that profit maximizing firms will be following? Next, we will also learn about defining what does it take for a firm to be considered profitable and when do they become unprofitable. Next, why does it make sense to have a firm to behave differently in the short run versus the long run? As I have emphasized right from the beginning, that in all economic decisions, time is a factor. So we need to consider the behavior of individuals and firms in the initial response to a decision, in the initial response to a change in the market and how people behave, and then give them more time and see how they behave in the long run. So we'll talk about the difference between the short run and the long run to make sure that the distinction is clear. And finally, how does the short run industry supply curve differ from the long run industry supply curve when finally things get settled? Okay, so there are three factors or characteristics that I'm going to go over that will define a competitive market. First, that in such a market, there are very large number of buyers and sellers. And there are so many buyers and sellers that no one has a big share to have a large influence. Everyone has a small market share, and therefore they do not have the power to influence the price that's being charged. And therefore, everyone in this market, each of the many suppliers, the sellers, or the buyers, the consumers, will basically take the market price and make a decision based on that. All right? They are really a small player in the market. They do not have the power to influence. Is that clear to everyone? This is a very fundamental definitional point that I would want to make sure that you're clear on, that there are so many buyers and sellers in the market that everyone is a small bit player. No one has a large share of the market to be able to dictate what the price should be or how much they are willing to sell. They can sell as much as they wish at the going price in the market. Okay, let's test that concept here. There are four types of industries here, four sectors, and I'd like you to think about each of them and tell me if these industries, which of these industries will meet that test, that there are so many buyers and sellers. In this case, we are looking at the seller's side of it. And there are so many sellers that we would define them to be either competitive or not being competitive. So who would like to comment on the cable television industry? Define how many players there are, and does it fit the definition of a competitive market?
I think the answer is B, because all the other responses, television, oil, and farming, all have to do with location, but automobiles and trucks can be located anywhere. So I'd be guessing that there's more players in the market.
All right. Does anybody agree with that?
Yeah, I do.
I agree.
Okay. Is there anyone who differs?
I think the answer is D.
Okay. So now you give your reasons why automobiles and trucks do not qualify as competitive. Tell me what is the specific
No, I
answer?
said D, not B.
D. D is correct. No, you're correct. Now you can answer, you can help everyone else understand why the automobile industry and truck industry is not competitive.
Well, I just think for like farming, it's more of a competitive field just because there's more to deal with. Like that deals with where people get a source of food and then a ton of other things. Like it's just more important for like a bigger group of people rather than like transportation.
Okay, well,
So,
let's think of it in terms of the definitions that we have, right? What is the definition of a competitive market? Let me go back. First characteristic, and you're right, farmers, there are a lot of farmers, although we do have some big farming, agribusiness farmers also. But farming industry generally is characterized by small players in whatever market they're in. And therefore, they do not have the market share to dictate prices. So that's the first thing. They basically can sell at the going price, and therefore, farming qualifies as competitive, whereas automobile and truck industry, well, there are only a few sellers.
Isn't there only 3 main that own all the car dealers or
Well,
the
when you
different
look at
brands?
when you look at the manufacturers, how many manufacturers are? How many
It's General Motors, Ford, and the Chrysler, right? There's only the 3 big ones.
Well, you look at the international also. Look at the foreign producers. Mercedes, Toyota, Honda, all of these. But you can count them on your 2 fingers. On your 10 fingers. Whereas farms, there are large number of farms. They are small, and they do not have the power. Whereas the auto industries are large, and they do try to sell their products by differentiating them from others. Listen to the Mercedes advertising, for example. What is their message at the bottom? Right? It is the best, or if it's nothing. They're the only ones who produce certain types of certain quality in their production, and that's how they try to sell their cars at a different price than the cars of others. So does everyone agree that D, farm commodities are the competitive markets, whereas the other 3 businesses, same with oil refining. How many oil refining companies are there? How many firms have drilling and refining oil refineries in the world? Right? You can count them on your fingers. So again, the emphasis is on the number of players and their power, their market share. Okay? All right, let's take a look at another one. Second characteristic of a competitive market, that they sell a standardized product. They are selling a commodity. They are not selling items that are different from others. All right? As far as the consumers are concerned, they see the product of each of the players, each of the sellers, as the same. And it is the view of the consumer that matters, not what the producers think they are doing. Not they think they are so different from each other. So in this case, as long as the consumers view the product being offered as the same, we consider that to be a competitive market. Is that clear? So we see the Christmas trees in the picture, right? There are a lot of people in your town maybe selling Christmas trees. Every garden center, every Home Depot, every local store, many houses of worship, many churches have their own tree selling programs and so forth. So the point is that at this point, no one. Let me just admit somebody who's waiting. Okay. So the second characteristic then is the identity, that is the standardization of what's being sold. Okay? All right. The third characteristic of a competitive market is that there is free entry and exit. What does this mean? That it is not so difficult to enter this market, to get into business in that particular sector, and it doesn't cost a lot if you wanted to leave the business. You don't lose a lot of money if you end up being driven out of the market, or market failing. Right now, for example, restaurants are failing because of the conditions due to the coronavirus pandemic. And there are different kinds of statistics, but we are hearing that nearly 40% or even more of the restaurants will probably never come back. They simply cannot sustain themselves. They don't have the cash to be able to carry on. Very, very few companies, large companies that have investor groups that are able to operate in this environment. Okay. So the third characteristic is entry and exit, that it's easy to get into the business. And we'll actually spend a few more minutes on defining what are these characteristics, what does it take, when is the free entry and exit possible. We'll see what it takes to get into the business. All right. All right, now let's take a look at some more specific definitions. What is a standardized product? What do we call a commodity? And the advertising by different producers might say that they are the ones who are the best, and that they're different from others. Different kind of sushi, for example, being advertised by Korean restaurants versus the Japanese. And as I pointed out earlier, what matters is the view of the consumer, not what the sellers say in their advertising or in their product labeling and so forth. What matters is what the consumers think. And as long as the consumers view the product being the same, then we have the condition of a competitive market is met by that perception. Okay, so now we've defined what a competitive market is. So we're going to talk about the decision-making process. And in order to do that, we need a few definitions. Okay, now let me get back for a moment before we get into these definitions. Let's go back and define the three characteristics of a competitive market. Who would like to share with everyone what are the three characteristics of a perfectly competitive market? What's the first one?
There must be a small market share.
Small market share. In other words, the number of sellers and buyers is so large that no one has a large market share to be able to influence the price. Everyone has a small share. They are a small bit player, as we say in the vernacular. Good point. Next one. What's the second characteristic? Anyone?
The industry must produce a standardized product.
Right. The product being sold in this market is standard. It's a commodity. And what is important in defining what is considered a commodity? Whose view counts? Is it the view of the sellers or the buyers?
The buyer.
It's the buyers. As long as the buyer thinks that everything is the same and they are choosing among the many things, many different sellers, that is the characteristics of a standardized product. And the last and final
Easy entry and exit.
Okay. So that means that it is not a big deal. It doesn't require a lot of capital to be able to enter the market, and you don't lose your shirt. You don't lose a lot if you end up failing and having to leave the business. Okay? All right. So under those conditions, then, we are going to study what other factors that the businesses need to consider when they are making decisions. The decisions that firms need to make are two types of decisions: what to make, what industry they want to enter, and how much to make, how much to sell. So in order to get to that point, we are going to be defining the rules that the companies follow for the level of production. Because once people have decided, that's their business. So whatever business they're in, the economic question is going to be, what are the rules that will govern the decision-making process of individual firms, these small firms that are in this business? So we define each firm as a price taker. In other words, they are not determining the price. Their market share is very small. And all we need to consider is how do they decide how much of the product they want to bring to the market? All right. So a few definitions now. First is total revenue. We discussed total revenue before. Total revenue is simply price times the quantity. And the price is fixed by the market. Quantity is what the firm is going to choose. How much, that is, what is the volume of their production? What is the size of their plant? Size of their factory? How big do they want to be? All right. And the next definition we would like to understand is the profit. What is the definition of profit? Well, it's simply total revenue minus total cost. And we recognize that the firms are going to focus primarily on this measure of the business, profit. How much profit do they make? And we assume that people who are in the business, they want to maximize their profit. They want to make as much profit as they can, allowing, given what the market conditions are. Okay? All right, let's think about this company. Here we have, okay. And let me go to full screen so we have a slightly better view. Using the marginal analysis to maximize profits. So here is our well-known friend in economics, marginal analysis. And now we are coupling marginal analysis with profit maximization. So firms, their main goal is to earn as much as possible. And in economics, we would like to know, how do they get to that decision? And one of the rules we are going to find is that I'm sorry, we went too far. Let me go back. All right. I was really trying to scroll up here. Okay. All right. So in this chart, get this out of the way here. Okay, you can see the full chart now. What we're showing here is the quantity of trees being produced in the first column. We recognize the market price is $18 per tree, and therefore the total revenue shown in the second column is $180 when the output level is 10, all the way up to 70 trees being produced, and the total revenue the company earns, or this farmer would earn, would be $12.60. Total cost given to us is $140 fixed costs. That is, in order to be in business, you got to spend at least $140 to have a farm stand where you're going to sell the trees, right? So that's a fixed cost. And then as you add the number of trees, the total cost, which includes the fixed cost and the cost of the trees, is now going up. So, for example, when we sell 10 trees, when we have 10 trees to sell, the cost, the total cost is $300. Okay, when it's 20, it's 360, and so forth. Profit in the last column, defined as total revenue minus total cost. In the first row, we see that the person is losing. They spent $140 and no sales because they haven't any trees to sell. In the second one, in the second row, when they have 10 trees, they're still losing money. Okay, so obviously they want to continue selling more because they are interested in making as much money as they can. So 20 trees breaks them even. They just barely cover their total cost. 30, you bring in $100. 40, $160. 50, $180. Now, as they go beyond 50, you go to 60, it turns out that their profit actually drops to 160. So where's the maximum profit? What's the level of output where the maximum profit is realized?
50.
Is 50 trees. So this is the point where marginal analysis will tell us that the marginal revenue is equal to marginal cost. That is, the additional revenue you bring in for selling one more tree is equal to the cost of selling that tree. All right? So this is again the definition. So now marginal revenue is defined as change in total revenue generated by an additional unit of output. The marginal revenue is delta total revenue divided by delta Q, delta output. So for the price-taking firms, small firms, marginal revenue is simply the price in the market because they can sell as many trees as they want at the going price. So the optimal output level for the profit maximizing firm is going to be the quantity which yields the marginal revenue, which is equal to the cost, which of course is the price at which they can sell, because they cannot control the price. Okay. So let's explain what this means. Profit maximizing output, where marginal revenue is equal to marginal cost, can be best understood from the view of the firm, which is trying to get to a point where they are at an optimal level of output, which means that they're getting the highest profit, beyond which they would actually get a lower level of profit. So this method tells us that as long as the marginal revenue is greater than marginal cost, there is an incentive for the firms to continue to sell because it will add to their profits. But we recognize that as soon as they reach that point where the marginal revenue is equal to marginal cost, or if it begins to fall below marginal cost, then obviously adding one more item to sell is going to bring them lower profit per unit. All right? And in this case, since we know in a purely competitive market, we know what that marginal cost, what the marginal revenue is, right? Marginal revenue is simply the price. Because for every additional unit they sell, they can only sell it at that same price. So marginal revenue equals the price. And of course, by definition, then, it should also mean that the price is set at the marginal cost. So the market will determine what that marginal cost price is, but the firms, individual firms, can use that price as the guide for their marginal revenue. And as long as their cost is below the price at which they are selling, they are maximizing their profit. So let me pause here and ask if everyone is clear on this definition and the rule, or the maximizing rule, the profit maximizing rule, or the rule for deciding what the optimum output level is. So the optimum output rule is marginal revenue equals marginal cost. Does anyone have a question? None? Let's go. All right. So costs and production in the short run. As we begin the production process, initially, as we can see in this example, we're using the same data, and we are now going to break down the cost so that we understand the difference between variable cost, total cost, and marginal cost. So please pay attention to these three definitions. All right. So starting off, when there are no trees to sell, there is a fixed cost of $140, and that is also the total cost at that point. Once we start selling, so for 10 trees, the variable cost is $160. Okay? The farmer is able to produce a tree at $16 per tree. So 10 of them cost them $160, right? So when we add the $160 to the $140, the fixed cost that they had, we get a total cost of $300. 160 plus 140 gives us 300. Is everyone clear on that?
Yeah.
So the definition of total cost is fixed cost plus variable cost. Okay. Let's go to the next point. So when the person, when you are at 10 trees, so what is the marginal cost of a tree? As we said earlier, that going from 0 to 10, you got an increase of output of 10, right? And we see that the total cost has gone up by 160, right? So 160, that's the change in the total cost divided by the number of trees that we added, change in the output, that's the delta Q, we get $16. The marginal cost is $16 at this point. Is that clear?
Yeah, Professor, I need to find out the how is can we find the variable cost if each one, like first one is 0, second one is 160. So
Okay, okay, go ahead. So why? Okay, try to verbalize the numbers that are shown in the variable cost column.
yeah.
Now, the definition of a variable cost, of course, is that it is the cost incurred by the firm
Yeah.
as it varies the number of items it begins to sell, what it wants to produce and sell. All right? So in this case, when there is no production, nothing being sold, output level is 0 in the first row of this table. We say variable cost is 0.
Yes.
But we show total cost of 140 because
Yes.
that reflects the fixed cost. Okay?
Yeah.
All right. So now let's look at the next line where we say, okay, this farmer is going to sell 10 trees.
10 trees.
All right. And the variable cost of total variable cost, if you want to use the term total variable cost for the 10 trees, is shown in the second column as 160.
Yes.
So $160 is the total variable cost for 10 trees. And then we see that when we add the 140 fixed
Yeah,
cost that
300.
we had, to the 160 variable cost,
Yeah.
we get the total cost for 10 trees of $300.
Yes.
Okay. So now we want to derive the marginal cost. We went from 0 trees, right? 0 trees to 10 trees.
Yeah.
So we increase our output by 10.
Yeah.
That means the delta Q, the change in quantity,
Okay.
is equal to 10, right?
Yes.
Now, the change in the total cost, now let's take a look at this column. It goes from 140 to 300.
Yeah.
Okay, and that increase is $160. That is the variable cost that was incurred for 10 trees.
Yeah.
So therefore, if we now take the delta total cost, which is 160,
Yeah.
divided by the delta Q, which is 10, we get $16 as the marginal cost.
Yeah.
Okay, it'll become more clear when we look at the next one.
Yeah.
Let's say we go to 10 trees.
Yeah.
So for 10 trees, okay, we are finding that the variable cost is 220, 20 trees rather, I should say, okay?
Yeah.
So now we add 220 plus 140, the fixed cost, we come up with a total cost of 360, all right?
Yeah.
All right, so in this case, the delta cost, what is the cost, the delta, what is the change in the total cost? It went from 300 to $60, 360. So the increase in the total cost is 360 minus 300. So that is $60. So $60 is the delta total cost.
Okay.
What is the denominator? The denominator is the number of trees being changed.
Yeah.
So we went from 10 trees to 20 trees.
Yes.
So what is the delta Q?
Yeah. 20.
No, what is delta Q? What is delta Q for this row?
20.
No, how can it be 20? It's delta. Delta meaning the change.
Oh, so 10.
20 is the total output. What is the change from 10 to 20?
So 30.
No.
It's 10.
Let's go back.
Okay, minus to the minus.
You got to subtract. You calculate the change
Okay.
by taking the new level of 20 minus 10.
Okay, minus. Okay.
The difference is 10. Okay?
Yeah.
How much did it change by? It changed by 10. So
Okay.
if the cost changed by 60, went from 300 to 360,
Mhm.
right?
Yes.
So the numerator is 60.
60.
The denominator is delta Q, which is 10.
10.
So 60 divided by 10 gives us the marginal cost of 6.
Okay.
Now, at this level, while we still have the number of trees being produced, let's say, as 20, right?
Yeah.
The price is still 18,
Okay.
right?
Mhm.
So we know that that price represents the marginal revenue. For every tree they can sell, they can generate a revenue of $18. All right. So we go to 30 trees. So we increase the output from 20 to 30. Again, the delta Q is 10.
10, yeah.
Let's look at the delta total cost. What is the change in total cost? I want you to give me the number. We went from 20 trees to 30 trees.
Yeah, 10.
So we look at this column, total cost. Please calculate the difference in the cost. What is the increase in the total cost from 360 to 440?
80.
That's 80, exactly. So the numerator is 80.
Okay.
What is the denominator again?
10.
Yes. So 80 divided by 10 is 8.
8. Okay.
So that's how we get the marginal cost of $8.
Okay.
Okay?
Different.
When you're going from 20 to 30.
Okay.
All right?
Got it.
So same way, we continue. If you go from 30 to 40, the marginal cost is 12.
Yeah.
When we go from 40 to 50, the marginal cost is 20. But when we go from 50 to 60, oops, all right, we find that our marginal cost is now, okay, I need to get this off here. Okay, all right. So that we see that the marginal cost is actually beginning to go up, right?
Yes.
So that is why we find that at the point of 50, the marginal cost is equal to the marginal revenue, which is the $18 price. And therefore, the 50 output level is the optimal level of output. Is everyone clear on that?
Yes, yes.
Okay. All right. So definition says that the companies will produce that level of output in order to maximize their profit where marginal cost is equal to marginal revenue. That is, the additional revenue they get in from every sale they make is the same, is equal to marginal cost, and therefore that is the optimal level of output. Okay, so now let's go to the next one. So now we want to make a distinction between the short and the long run. Okay, we say that in the short run, the plant size is fixed. You know, how many trees they can sell, you know, they have so much space, they cannot increase it right away. We have to look at the conditions that they have to face. So we focus on the short run profit maximizing, and the plant is fixed. They cannot change the size of their plant. And that's the definition. Now, usually in economics, we define the short run to be a year or less. Okay? So the firms make a decision, they operate, they're able to operate for a year at that level. But beyond that, they can decide if they want to increase the size, and that's when they are able to vary certain things and be able to sell more or less, whatever they decide. Okay. So now let's look at everything graphically. We're using the same concepts, but we're going to put them in a picture now. All right? Here you recognize marginal cost, you recognize marginal price, and this line of blue line at $18 is the market price. And we recognize that because we are in a purely competitive market, each firm can basically sell whatever they wish at the market price. And therefore, the marginal revenue is equal to the price in the market. All right. So the question is, what is the optimum level of output? And in the table, we determined it was 50, profit maximizing quantity, and the profit maximizing price, which is given in the market of $18. And we see that at this point of $18, the marginal revenue curve, which is horizontal, because the market is determining what the price is, and the marginal revenue that they can realize is fixed. Now, we look at the marginal cost. I'd like you to go back a couple of lectures and recall that we define marginal cost as the additional cost of producing one more unit, right? That is the increase in total cost as you increase the level of output by one unit. And we see that it has a behavior that in the beginning, marginal cost drops. That's because when you're starting off, the costs tend to be high, but as you begin to sell more and more products, that your marginal cost gets lower. But it hits a minimum, and then it begins to rise again, as we saw in the table. In fact, let's go back to the table and see the numbers, okay? Let's look at this marginal cost. See, we're starting off at 16, dropping down to 6, and then it beginning to go up to 8, 12, and 16 again, and then 20 and 24, and so forth, okay? So we recognize that the cost behavior depicted in this picture is what we would expect in a competitive market. Okay? So as market price, the number of output, number of items that the person wants to sell is increased, the marginal cost continues to rise. But they reach a point where the marginal revenue line intersects with the marginal cost. So at the point of output level of 50, we see that the marginal revenue is equal to marginal cost, and therefore that is the profit maximizing level of output or profit maximizing quantity that the firm is going to produce. All right, let me pause here for a moment and ask if anyone has a question. This graph simply translates what's in the table. So if you were given the data that's in the table, you should be able to produce this simple graph. Any questions? Hearing none, let's continue then. All right. So what if marginal revenue and marginal cost aren't exactly equal? So as I said in the beginning, in economics, we try to simplify the world, a very complex world, complicated situations. We try to simplify it to a point where we can use simpler concepts to define different, items that we need to make a decision. So we really recognize that output could be a little bit, higher or lower than that, at which the marginal revenue and marginal costs are equal. But generally speaking, we ignore those fine details and we generalize based on the simplification that as long as the marginal revenue is equal to marginal cost or it's higher, that is the level at which people are going to be selling. All right. So in the short run, as I said, the numbers could be a little bit off. They may not be exactly equal, but we are talking about being in the neighborhood, being in the range. So this picture that we were looking at, that in this range of price, which is set by the market, and this is the level of output, that the marginal cost and marginal revenues are equal. But as I said, these numbers could be a little rough. So perhaps you could draw a little circle around this one, because the price line is fixed. That you know pretty clearly from the market data. The marginal cost could be a little bit off, but for our purposes, it doesn't matter. We want to simplify the situation to a point so that we can make a decision. Okay? All right. So generally speaking then, we come to the conclusion that when we use economic profits as the rule, right, which includes all the costs, including explicit and implicit costs. So it is a normal for the firm's economic profit to be zero. So when the total costs are being covered, that actually includes the cost that the owner is incurring. And whatever is assumed to be or attributed to be, or what we sometimes refer to as, implicitly assumed to be the cost. So the rule is standard. If the total revenue is greater than total cost, the firm is obviously profitable. When total revenue is equal to total cost, they're breaking even, and they're breaking even because they are covering their costs. And when the total revenue is less than total cost, then the firm, of course, is going to lose money. All right? So that is another way to look at the profit maximization rule, that is, as long as the firm is at a point where the total revenue is equal to or higher than total cost, it'll be making money. If it falls below that, they will be losing money. Okay, now we're going to introduce one more curve into that picture. Previously, we just had the marginal revenue at price. We had the marginal cost. And now we're going to add the average total cost curve. Okay? Now, this purple curve represents the average total cost. Now, what is the average total cost? How do we define it? Let's go back to the table. In these, in this column, we see the total cost going from 140 to 1160. And here we have the quantity. So how do we calculate the average total cost? Well, the average total cost is taken from the total cost divided by the total quantity. Okay? So TC divided by Q would give us the total cost of the average total cost of the firm, average per unit being produced. So we see this picture, starting off at a high cost of 30, and then average, that is, coming down and intersecting with the marginal cost curve. Okay? And this is something we're going to spend a few more moments on. Understand that the behavior of the average total cost is such that it begins to fall in the beginning as you increase the level of output. And it is still above the marginal cost, as you can see. The purple curve as being the average total cost, being above the marginal cost. Okay? We recognize two things. One, that it is falling during this range, but it is still above the marginal cost. Once it intersects the marginal cost, then we find the average cost is lower, average total cost is lower than the marginal cost curve. Now, they're both rising, right? Average total cost is rising a little bit slowly, with the marginal cost increases at a higher rate, all right? Of course, the marginal revenue is still equal to the price in the market. So in this case, the break-even point occurs at a price of $14. And the maximum, the minimum cost output or the maximum profit output is 40 in this case. So if the price is just high enough to cover the average total cost, and if it chooses the quantity level where marginal revenue is equal to marginal cost, the firm is breaking even. They're just covering their average total cost. Any questions so far? Okay, let me repeat the two significant characteristics of these two curves. The relationship between the marginal cost and the average total cost curve. So looking at the range of output, as the level of output increases, these costs will vary. And we find two things. That in the beginning, marginal cost drops, reaches the minimum, and then it begins to go up. We can see the same thing. Average total cost also drops. That is, the per unit cost of producing these items is going to be falling as we increase the size of the output, how many units we produce. Now, in this case, at the output level of 40, we find that the average total cost has reached its bottom. Okay, it's reached its minimum. And then it begins to rise slowly. Also, the marginal cost curve that had been falling for a while it's now rising and has actually been rising before the average total cost begin to rise. So the marginal cost intersects the average total cost from below at the minimum point of the average total cost. As you can see, this is where the average total cost is at its minimum. So that's the point at which we find that the optimal output is 40 in order to minimize the cost. Okay. Any questions? If not, we can continue then. Okay. So now let's understand the profitability. The market price is fixed at $18, right? So we see in this picture, same blue line at $18. This is our average total cost curve, right? And we saw in the previous example that the average total cost is equal to the marginal cost at the price of $14, okay? And we see the same picture. Average cost falling in the beginning, reaching its minimum, and then beginning to rise slowly. Marginal cost curve also falling initially, rising, and it intersecting the average total cost curve at this minimum point and then rising above it. Okay, so if the price is higher than the average total cost, right? So in this case, the average total cost, okay, oops. Okay, let's move this image a little bit. Okay. All right. Let's get back to our chart. Okay. I need to get back to a chart here. Okay, here we go. That's the chart we were at. All right, let me go to full picture. Okay. Okay. Hopefully you can see the whole picture. There's a little bit of the image is covering it, but I think it's pretty clear. The points that I want to make are really relevant in this part of the picture right here. All right. So what do we have here? We find that if the market price is $18, if the break-even price of the firm, oops, sorry. Okay. We find that the break-even for this firm occurs right here, okay? The firm's unit loss, we can also understand what will happen. So this is where we're showing the profit. The price is higher than their average, the bottom of the average total cost, where marginal cost is equal. So they are able to sell 40 trees and make a profit, right? So this green rectangle gives us the profit level, all right? Now, if the farmer actually gets to a point where if you look at 30 trees, right? What's the situation here? Their average total cost is higher than the price, all right? So we find that they're going to be losing money, and that picture shows the loss. All right. So the graphs are usually designed to help us visually understand where the firm is going to operate. We will see that the optimal level is where marginal revenue is equal to marginal cost, optimal level of 50. But at other levels of output, it could be making a short-term profit or actually losing money. Okay, so in this case, we find that the firm is going to lose $4.67 on each tree. All right, and the total loss would be about $14. Okay. All right. So the question is, do we stick to the short run? You don't really, even if you're losing money in the short run because your costs are higher than the price that you're able to get, you can increase the level of output and get to a point where you can spread your fixed cost over a larger number of items, and therefore you will continue to expand until you reach the optimum level where you are making your economic profit. Okay, we're going to take a break at 10 o'clock. And let me see, how many more slides do I have here? Okay, yeah, we should be able to finish that. All right, so let's go to the second part. The question is, should I, stay in the short run, or make a decision to go ahead? So firms will have to choose, even if they are losing money, to deciding if they're covering some of their costs in the short run. They will take a certain loss, but you reach a point where if you cannot cover even your minimum average variable cost, right? If you cannot even cover your minimum average variable cost, that every unit you sell, you're losing money on it, right? Therefore, that is what we call the shutdown price. That is when you decide. That's why many restaurants have decided that it is no longer profitable for them to continue to stay open, and they shut down. Okay?
I have a question.
Yeah, go ahead.
So how would you fix that?
Well, you fix it by either lowering your cost. All right. If you have a way of becoming more efficient by lowering your costs, you can stay in business. But if you cannot even cover the minimum variable average cost, right, then every unit you sell, you're losing money at it. Then it makes no sense to stay in business. Economics will say that then you should get out of business. Okay? All right, let's take a look at another question. Here we want to emphasize the concept of the economic profit. All right? So if, in this case, you're a competitive firm, you're producing where the marginal cost curve intersects the average total cost curve from its minimum point. And at that point, what is the firm earning? Is it making positive profit? In other words, non-zero profit something above zero? Is it making zero economic profit? Or is it running a short-run loss? All right, let me go back to the picture so you can see where we are. This is where the point is, right? So when you have the average total cost at its minimum equal to marginal cost, at that point, is the firm, let me go back to the question now. That's the question for us. Which one of these statements is correct?
It will be zero economic profits.
Zero economic profit. Okay.
Because the market price equals the minimum average total cost.
Correct. So at that point, they are making zero economic profit, but economic profit means that they are actually do have all of their costs covered. Explicit and implicit costs are covered, and therefore they can stay in business. All right. Now, next question. Should a competitive firm keep producing even if it faces short-run losses and is producing at a point on its marginal cost curve, which is above the minimum average total cost curve? So the question is, yes, it is earning normal profits. Yes, because it covers its variable cost and some fixed cost. No, it should never incur a loss. So the question is, should a competitive firm keep producing even if it faces short-run losses? Okay, so our rule is that you can face some short-run losses, but as long as you're covering your average variable cost, you should be able to stay in business, right? So in this case, what's the right answer? Anyone?
Is it B?
Yes. So help us understand why you believe that is the appropriate choice. Should a
Because
competitive firm keep producing? Should it stay in business even if it faces short-run losses and is producing at a point on its marginal cost curve where above the minimum average variable cost? So it says that as long as you are covering your minimum average variable cost, you can stay in business because you are covering your variable cost and some of the fixed cost. So you're not covering all of your fixed cost. So you can take a short loss. And the idea is that in the long run, you can expect that the condition would improve and you would be able to reach the optimal level at which you will be making a positive profit. Positive, zero economic profit, where the ultimate choice will be. Okay, so let's now add one more curve. We're going to now add average variable cost curve to this picture. All right, so average variable cost, this purple curve here, is defined as the average variable cost equal to the total variable cost divided by the quantity being produced. And obviously it is below the average total cost at every point. Why is that? Why is the AVC, the average variable cost curve, below the average total cost curve at every point? What's the difference? What does this gap mean? Anyone? This is a matter of definition. And I'm going to ask you to please confirm your understanding of the definition. All this picture is showing is the data that we saw in the table. And what did that table contain? It showed average total cost. I mean, it showed the total cost from which we derive the average total cost curve. As the quantities change, as we go from 0 to 10, we get one number, we go to 20, we get another number. Quantity. And average variable cost dividing average total variable cost divided by the total quantity gives us this curve. Why is this curve below the average total cost curve? What's the difference? I'm not going to move until you give me an understanding that you're clear on why that is different and what accounts for the difference. Let me help you with a few charts before where we see the different components. By definition, seeing these numbers, does that help?
Is it because the variable costs are always less than the total costs?
Correct. And what's the difference between the two? You're absolutely right, but what is that difference?
Is the variable cost constant?
No. Variable cost is varying. It's varying with the quantity. I want you to look at the very first row in this table. You have a clue. Whoever said the variable cost is, is going to be below the average total cost is right. And the difference is accounted for what's in the first line in this table. What is that number? You don't see the words on this table, but the data tells you, and the definitions should be clear to you to see what that means. Okay. Okay, whoever answered that question correctly, let's just read this table right across. On the first row, what are we showing? We're showing no output being produced. Variable cost is 0 because we are not selling anything, right? We don't have anything to sell. There's no variable cost. But in the total cost column, we have a number, $140. What is that? What is that number? What does it represent? I don't mind waiting until, I see one of my goals is that, hopefully as we go along that you understand the concepts and I try to come back to these things to reinforce them. So I need somebody to identify what that 140 represents.
Is that going to be how much it takes or how much it costs to produce or make 0 trees?
So you tell me, when you're not selling any tree, what is that cost? What do we call it?
Total cost.
Fixed cost. You're absolutely right. So in the first row, The number in the total cost column represents the fixed cost. And now, excuse me, you can see that when you calculate the average, that is this total cost number divided by the quantity, that will be the average total cost, right? Including the fixed cost here. That's embedded in these numbers, right? Each of these numbers has that 140 embedded in it. But when we calculate the variable cost, average variable cost, we are dividing this column, average variable cost, where the fixed cost is 0, right? So now I'm going to go back to my picture and tell me why the one curve is below the other. What accounts for the difference? Now we have the answer, right?
Fixed cost.
The fixed cost. Yes, absolutely. And you see, this gap is big in the beginning because that's a $140 difference right there. Per tree, it's 140 divided by, that's a difference of $14 from here to there, right? By the time I get here, that 140 is now divided by 30, right? Correct? So it's the fixed cost is getting spread over the larger number of units. That's why the gap between these two is being reduced as we go. So, but the average variable cost is always going to be below the average total cost because it doesn't include the fixed cost. Average total cost includes the fixed cost. Okay? I can tell you when I studied economics in the 1960s, first in Pakistan and then at the London School of Economics. When we used to look at these pictures, they were just sort of vague pictures of something, right? And in the very beginning, it was kind of hard to identify everything and clearly define. And that's why I'm really spending more time with you to help you begin to relate to these concepts, definitions, numbers, and curves, so that you really understand that they say the same thing, okay? But they're shown differently. So understanding the graphs in economics is a big part of the learning, really. If you can interpret the graphs and know what the graphs represent, what numbers do they really show, you have won the battle of learning what economics is all about. Okay? So that's why I try to emphasize that we always look at what does it really mean? What does it show? What part of real life do these graphs represent? Well, they're telling us the firms are looking at those numbers, and based on those numbers, economics tells them, at what point you should be making a, zero economic profit, which is right here, which at what point, you are at least covering your variable cost and you can continue to operate. But if you can't even cover your variable cost, you should get out of business, right? That is what these pictures tell us. All right. What is the meaning of the, average total cost curve, the marginal cost curve, and even the variable cost, all declining in the beginning, reaching a certain minimum point and then rising? That is real economic behavior. We see that in business. And the reason why this behavior is there is that there are certain costs that have to be covered, and these curves will show that. And the difference between these two then is the absence of the fixed cost when we only look at the variable cost. We are basically saying fixed costs are sunk costs, right? Once you've spent the money, you've opened up a business, that's it. You can't change it, right? So just ignore that. Now focus on how many trees can you sell? And if you are selling trees at least at a point where you're covering your average variable cost, right, you should be okay. Stay in business in the short run. And because in the long run, you'll be able to expand your business and actually be able to earn a profit. All right, let's take a 15-minute break. We'll come back at 10:15 And I will quickly finish the rest of this chapter, because I think if you've got this part, the rest is easy. And then I'll do a review of what you can expect in the test, okay? Okay. So now let's talk about the very topic that I was trying to emphasize, the fixed costs. Can everyone hear me?
Yes.
Good, good. Okay. All right.
Yeah.
So let me move this bar here somewhere so I can get the full image. Okay. Now you can see why I was focusing on fixed costs. Fixed costs are clearly critical to start a business. And in the short run, you make a decision. But obviously, in the long run, you have the ability to change the size of your business. And we are going to try to understand for the rest of this class as to what that means. All right. So we say that average, as long as the price that is prevailing in the market. Now we try to understand, how businesses expand. How do they increase their supply? Right. That's what the supply curve is all about. It shows that if the businesses can expect prices to rise, they will be expecting to sell more, right? So if the price is above the break-even minimum average total cost, firms are profitable, right? Because they're covering their positive profits. Now, if the price actually rises above that level, that is what attracts people to come in. All right. I'm going to just go back for just one moment to point out the significance of the graph again. All right. I mentioned the supply curve. And it turns out that based on the definition that we have, that this portion of the marginal cost curve, starting with point A, okay, above the average variable cost. Remember, that's where we said that is the shutdown point, right? So that's the point at which you just shut down the business. So if you are able to continue the business and expand beyond it, level of output rises. This red line then, the marginal cost curve, actually represents the supply curve of the firm, because that just shows that as the prices begin to rise, people are able to bring more and more quantity to the market. And therefore, this portion of the marginal cost curve above the average variable, minimum of the average variable cost, is really the short-run supply curve of the firm. Okay? All right, let's go back. So this is what we are talking about. So the industry supply curve then is really, as the prices begin to rise, the obviously output begins to increase. So the short-run industry supply curve shows how the quantity supplied by an industry depends on the market price given a fixed number of producers. In the long run, obviously, you can change that. So a short-run equilibrium occurs when the quantity supplied equals the quantity demanded. Obviously, given the number of producers is fixed at that point. That's the definition of a short term. In the long run, obviously, more people can come into the business and they begin to increase. So in the short run, we can see, remember, this is the marginal cost curve I was just showing you in the previous graph, right? That is the supply curve. And it is a demand curve, just to illustrate the point. So the equilibrium occurs at point E, where the market price is equal to, and the quantity is 5,000 trees, and the price of $18. Okay. And remember the shutdown price? Again, going back to the same picture that I showed you before. That's how we know that the bottom of this supply curve is shut down. In other words, why you don't see this curve extending beyond it is that it doesn't make sense to stay in business at that point. If the price falls to $10, you can't make any money. And on every single tree that you sell, you're going to be losing money. And that's why we would, start the marginal cost curve here. And that's why this is the supply curve. Does it make sense? You
Yes.
understand why these pictures are really important to understand? You see, this is the same red portion of the marginal cost curve that I'm now showing as the supply curve. Okay? So here's the reason why I emphasize the graphical picture so that you have an image in your mind, and hopefully it will help you understand how the market behaves. Okay, so now this looks a little complicated, a lot of stuff on it, but what does it say? That in the long run, businesses are able to expand. And as long as there is profit to be made, more firms will enter. Okay? So here we have, short-run supply curves that we are seeing. Okay? And ultimately, when you add up, you get the long run for the market. And again, for an individual firm, you can see the marginal cost curve representing the supply curve, right? And here we see where they are making money at a price of $18. What happens at a price of $16? Okay, they're still able to make some profit, but if the price drops, this is where the break-even price is, right? Whereas the average total cost is equal to the marginal cost and the price at that point. That is the break-even price. But if you go even below that, that is where the variable cost is, at its minimum. That's where you actually shut down. So the basic notion is that as long as the price is above the, minimum average total cost, market in the long run equilibrium, people would supply the quantity being demanded, and the market will expand. All right. Here we just show you the movement. The existing firm response increases in demand. So when the demand increases, okay, companies will respond to that. So if we see the demand curve shifting from D1 to D2, now an increase in demand, we recall, is a shift in the demand curve. And here we see that in the long run, when people see the demand has actually increased, the market is opening, more but businesses will enter. So supply curve shifts from S1 to S2, that more people will enter the business, and the industry then will be able to meet the total demand. And the equilibrium in the long run would come in once the new entrants come in and the market settles down. So the long run short curve, supply curve shows how the quantity supplied responds to the price, because as the prices begin to rise as a result of the increase in demand, you will see more firms entering and an equilibrium being achieved. Okay. So comparing the long and the short run, what do we have? We recognize that because there is free entry and exit, remember, that's by definition of a competitive market, that firms will enter and exit as the conditions dictate. So a higher price will attract new businesses. They will come in. So in the long run, the industry will be increasing the supply and lowering the price for the consumer. A fall in the price obviously would force people to exit the business, and they will reduce the number of producers and output, and the prices will begin to rise in that case. So this is what we understand from the dynamics of short and long run. So what is economic profit again? We want to emphasize why should a firm want to enter the industry if the market price is only slightly greater than the break even, right? We use the economic profit, as you say, as an indicator of what where they would actually be able to still stay in business. So if the market price is above the break even level, no matter how slightly, the firm can earn more in this industry than it could elsewhere. The opportunity here would be for them to make money. All right. So the long run market equilibrium in a perfectly competitive market industry with identical firms results in all firms. Where do they end up? Earning zero economic profit, reducing the quantity associated with the break-even price, reducing the profit maximizing quantity where marginal revenue is equal to marginal cost, or all of the above. Which one of these things you think is right? Okay, let's go through it one by one. We will recognize that by definition, as long as the firm is making a zero economic profit, they can stay in business, right? We just went over that. So A is okay. Reducing the quantity associated with the break-even price. Remember, the break-even price is where they are at least covering their average total cost. As long as they're covering their average total cost, they can stay in business. C, reducing the profit maximizing quantity, where the marginal revenue is equal to marginal cost. That is our fundamental principle of profit maximizing. Businesses will continue to produce, continue to increase their level of output to a point where their marginal revenue is equal to marginal cost. So all of these statements are true in this case. Okay? All right, so that brings us to the end of chapter 12. So before I begin the review, let me ask if there are any questions.
No.
Yes, go ahead.
No, I don't have any questions. Sorry.
Okay, good. All right. So as far as the review is concerned, so let me go back to the point of the test. I've set up the test. You should be able to check it. Can somebody take a look and see if you can actually see the test? So I want to make sure it's open. Just go to modules. And go to practice test 1, chapter 3, 6, 9, and 10, worth 100 points.
I can see the practice test, yes.
Okay. So here it is. Here are the directions. It's worth 100 points, but that is just illustrative for you, so you know how well you're doing. Okay, there is no time limit.
Okay.
Really quick, Professor, where is that? Because I don't have the modules tab.
Okay.
If you just go on
just open the home tab.
Turn the home tab.
Click on home. Okay. Oh, I still need to fix that part, right? You should be able to see those.
Yeah, you haven't unmuted the modules.
Oh, I see. I just had to refresh.
Yeah. If you go to the home page, I think that will bring you.
It's like right up top. I see it now.
Yeah.
Professor, next week the actual test is going to be 40 questions as well.
Yes.
All multiple choice, I'm assuming.
A multiple choice, true and false. Yeah.
Okay, thank you.
So I'm just looking at the student view, and you see announcements, grades, people, syllabus, and Zoom. I don't see the word modules.
Yeah, in student module, we're not able to see it because it's not yet
Oh, you can see it
published.
here. Okay, so let's see. The test actually is here. Yeah, the test is open to you. Yeah, you see it. Practice test 1 right there. Okay, good. All right, fine. Okay, let me leave the student view. Okay, so let's go back and talk about the significance of some of the concepts that we learned. And the chapters that I chose, 3, 6, 9, and 10, and I've taken basically 10 questions from each. There's a total of 40 questions to show you the variety. And in different attempts, you will get a different set of questions. So you'll have an opportunity to cover almost all of the content, depending upon how many attempts you make. Okay. So let's go over the one basic point that I wanted to make, and I try to do that in the illustrative answer that I gave you. And later on, after this class, I'll take some time to actually send you a spreadsheet with some examples of how you can show your work in the answer that you provide. Okay, that will help me understand. Even if you get the wrong answer in the end, if your numerical answer turns out to be incorrect, but if you have shown that you've applied the principles, the methods that I have been discussing, then you will get some credit and even possibly full credit, even if your numerical answer is off. As long as you have applied the methods that I've taught and the principles that we have mastered, you will get credit for that. Okay, so that's an important point. Again, to underline that the information that is given to you in any of the questions is meant to call upon you to use it to answer the full question. So if you are given an elasticity number and you are told that the change in the behavior, change in the quantity demanded is of a certain magnitude, well, then you should use that information to derive the answers to the question that's being asked. All right? Just giving a simple one-line answer as a bottom line doesn't help show me that you understand it. Okay? Again, the goal is for you to understand the concepts, understand the models, and applying these models and principles in trying to solve economic problems. So that is our goal. Okay? So let's look at chapter 3, supply and demand. I'll go in that order. Okay, I'm going to quickly bring up the slides for chapter 3. So give me one moment, okay?
So, Professor, you said the test is 2 hours long, right?
Yes.
Okay. So that's what, 3 minutes?
Yeah, I'll give you as much time. As I said, I gave you 2 hours, which I think is plenty for...
Yeah, that's like 3 minutes
for the 40 questions. Unless somebody, wants more, you have to think about that. Okay, so looking at supply and demand. All right. And in this picture, what I want to emphasize.
I can't see that.
Oh, you can't see it? Okay, let me, maybe I need.
12.
Hang on. Let me. It's on my. So what do you see now? Okay, let me see.
I see chapter 12 slide.
Oh, okay, you still see chapter 12 slides. Okay, so I think I need to stop sharing and do new sharing. Just 1 second.
Okay.
Stop sharing. Yeah. And we will start screen sharing, and I have to choose a different, yeah, okay, here we go. I just have to change the picture here. Share that. Okay, you see supply 3 now?
Yes.
Okay, good. All right. So I'm just going to go to some of the key slides in this one. Competitive market, right? We've already talked about the definition of a competitive market. What is a demand curve? Quantity demanded versus the shift in the demand curve with the demand schedule. That's easy. We're not going to worry about that. Shift in the demand curve, okay, represented an increase. So we make a distinction between the movement and a shift, right? A movement along the curve simply means you are looking at changes in prices and moving along the same curve, whereas an increase in demand represents a shift in the demand curve to the right if it's an increase, and if the demand curve shifts to the left, that would be a decrease in demand, okay? There is an example of that. Okay, let's go to substitutes. And as a matter of fact, in the very last test that you guys did, I was looking at some answers to the questions regarding substitutes and complements, and the subject of unrelated products. Like often you got a question that says, if the elasticity, if the cross elasticity between two products is 0, what does that represent, right? And clearly they are unrelated products. They are neither complements or substitutes, okay? Then the difference between a normal and inferior good. Now, the reason why differences in demand occur, they can occur due to changes in tastes, changes in expectations, and various other factors that can bring about change. Okay, let me go to this example here. The difference between the individual demand curve and the market demand curve, we simply add up the individual demands at this going price, if that's the market price of $5 in this case, for example. So if summing up the quantity demanded for this family plus the quantity demanded for this family gives us the total market. So market is a horizontal summation of quantities demanded at a given price, all right? Same thing with the definition of a supply curve. We just did it. In chapter 12, we got into more detail of answering this question that we had started in chapter 3, right? A supply curve shows the quantity supplied at various prices, and we now know that we can define the supply curve of the firm as the beginning of the average total cost point on the marginal cost curve all the way up as the marginal cost continues to rise. And that is how we get the supply curves, all right? So it is an example of a supply curve that we had covered in chapter 3. Same thing, the distinction between a shift in the supply curve and a movement along the supply curve. Shift represents an increase in the supply, shift to the right, that is, and a movement along the curve simply shows movement along the same curve when prices change. Okay? So this difference between the shifts of the supply curve can occur to a number of factors. And there will be some questions that are dealing with that, identifying those factors. We know that that can change as a result of input prices, price of the related goods and services, technology, expectations, and of course, the size of the market. If the number of producers increases or decreases, it will affect, as we just did in chapter 12, And you can see how the content actually ties in very neatly between chapter 3 and chapter 12. So we defined the basic concepts in chapter 3, and chapter 12, we actually went into the mechanics of how we can actually identify those factors, okay? Again, the shift in the supply curve, there's nothing new there, all right? Explanation of various changes. So for the supply and demand, the question that you will be getting will deal with choices of movement along the curve, shift along the shift of the curves, whether it's a supply or demand, and your ability to interpret them. Okay, and the equilibrium being achieved as the curves, supply and demand shift. If there is a gap between supply and demand, we will recognize the movement because individual firms and individual consumers respond to the conditions of surplus or shortages accordingly. All right. So you need to be able to just identify that. So that is chapter 3. I want to spend a little more time on chapter 6, which is supply, which is elasticity. Because you may get a few questions on that. So I'm going to stop sharing this one and open. Let me see if I can get chapter. Here. Okay, I think I got to stop sharing and I'll get you a new picture. All right, here we go. Here's how I can shift. So let me open chapter 6. Can you see chapter 6?
No, Professor.
Okay, then I think I need to share this one. Let's close this. And I have to share the screen and choose this and share. You see it now?
Yes.
Okay, good. All right. So again, this is the one I want to emphasize a little bit more. You to get some questions on this one.
Okay.
So we recognize the price elasticity of demand. And I cannot overemphasize the 4-level answer or a 4-step answer, if you like, to question related to elasticity. The basic question is, what is elasticity? We define the concept. Then we say, we actually expand it by saying the elasticity of price elasticity of demand is a degree of responsiveness to degree of responsiveness of the quantity demanded to changes in price. That is a general statement. Then we go and say, how do we measure that responsiveness? So in the next step, we say price elasticity of demand is measured by a ratio of the percent change in quantity demanded to the percent change in price. All right? So here is that definition. That's the second level, right? Then at the third level, we actually put in numbers, right? So here is the definition. You actually put in the number, the percent change in price versus the percent change in quantity, and we get that. Then the next level, now for actual calculation, we recognize that we have to use the midpoint method for actually making those computations, right? So in doing that, we use this definition. We have the same basic, the change in x divided by the average value of x. This is the midpoint. And the average value is computed by taking the starting value and the final value dividing by 2. That gives us the average point. And that's what average value of x is. So the midpoint says that instead of looking at the elasticity of demand at point A or point B, it is more sensible to consider the range between those 2 points. And that is how we calculate that. So here's an example of the actual calculation. All right, where we see the quantity, new quantity minus old quantity, divided by the sum of those two, divided by 2, okay, to calculate the percent change in the price. Percent change in quantity, same thing, all right? And then we calculate the elasticity from that. So that is the point that I wanted to make, is to make sure that you understand what those are, okay? Difference between different measures of elasticity. That in the short run, there are certain measures that we recognize that elasticities can change over time. But here are some examples that they do vary among industries. Okay. Let's go to a general definition. This is a very important topic. The concept of elastic, inelastic, and unitary elastic. The measure being that if the absolute value of the ratio of percent change to quantity demanded over the percent change to price, if that ratio is less than 1, we consider that demand to be inelastic. If it is greater than 1, we consider that to be elastic. And if it is equal to 1, that is unitary elastic. Now, if the number is less than 1, the actual magnitude of the number will tell us how inelastic that is, right? The smaller the number, more inelastic the demand is or supply. The larger number, if it is greater than, it is less than 1, but it is closer to, let's say, 0.8, 0.9, right? Then that means it is inelastic, but not as inelastic as it would be if the number was, the ratio was like 0.2 or 0.3. If it is, the same thing is true of elastic. If the number is greater than 1, we consider that to be elastic. But how much greater? If the elasticity, let's say we just had a few examples, or let's take a look at this example, right? Where we see that the housing market, for example, is an example of an elastic demand, because this ratio of the percent change into quantity demanded of housing divided by the percent change in price is 1.2. So the absolute value of that number is 1.2. That is greater than 1, therefore we say it's elastic. But compare that with the soda, Coke or Pepsi elasticity being 3.3. All right. So we say here that the elasticity of demand, price elasticity of demand, to be specific, is so much greater for soda than it is for housing, right? It's almost 3 times more elastic, more responsive, because you can expect a bigger response, relatively speaking, to the changes in price for soda than you would see the demand for housing, right? Take an example of the inelastic demand, the difference between 0.09 gasoline short run versus soda of 0.8. So here's an example of the difference between 0.8 inelastic in the short run, but 3.3 elastic, highly elastic in the long run. We recognize that there is a difference, and the elasticities would, in fact, would be larger in magnitude over the long run, and there are reasons for that. Okay? All right, so let me continue, and let's go. Okay, this is another topic, very important topic to understand, and you recently had some questions on that. The impact on total revenue and the relationship between elasticity and the revenue. right? We recognize the rule, if you remember, and I'll go to that picture and we'll come back if we need to get into more detail. So I would like to remind you of this picture. Let me get the actual picture here with the revenue. Oh, this is substitutes. Okay, let's use this as an example. Yeah, you will remember the discussion. That is, the elasticity has 3: 1, equal to 1, or greater than 1. If it's less than 1, it's inelastic. Equal to 1 is unitary elastic. Greater than 1, it's elastic. So we want to know what is the effect on revenue, right? And this question's asked you, elasticity of demand for eggs has been estimated to be 0.1, 0.1. That's an example of highly inelastic price elasticity of demand. Now, for the egg producers, if they want to raise prices by 10%, what will happen to their total revenue? So the relationship between revenue and elasticity, will it increase, decrease, or it won't change? So let's just use this as an example of a test. What do you think?
So the revenue would increase because it's you're raising the prices.
Correct. Does everybody agree with that? Does anyone think B or C would be the right answer? Okay, so in principle, we always remember that if the price elasticity of demand is less than 1, what is the reason why the revenue would increase? Well, if the elasticity is less than 1 or inelastic, it means that when you change the price by 10%, the quantity demanded will drop by a lot less than 1%. In this case, how much will the quantity drop by?
I don't understand.
Okay, answer. So
Well,
we'll try to rationalize as to why the revenue will increase, right? That when demand is in it, when price elasticity of demand is inelastic, we are saying that the revenue of the egg producers is going to increase. So now we want to understand the reason behind it. Okay. So I want you to use these numbers and say, why is that the case? What happens? When you increase the price by 10% and the elasticity is 0.1, I would like somebody to tell me what percentage change will occur in the quantity of eggs being demanded. Price has gone up by 10%. We know from the elasticity of demand of 0.1 that the quantity demanded will drop by a lot less, but by how much? I would like you to calculate that number. Remember my example where I said you take a look at your formula, right? The formula says elasticity of demand equals percent change in quantity demanded divided by percent change in the price. Remember that ratio? Okay. Now, on the elasticity side, if you just take 0.1 is the elasticity, right?
Okay.
Everybody agree?
Yeah.
All right. And on the right-hand side, we have percent change in quantity demanded, and in the bottom, we have percent change in price. So on the right-hand side of this equation, the denominator is 10, right? That's the percent change in price. So we want to know what is the percent change in quantity with the elasticity being 0.1. So just imagine that the 0.1 on the left-hand side of the equation, I wish I could show you on a screen, that 0.1 and put a line under it and then put a 1 under it, okay? Because 1 doesn't change anything. So the equation now reads 0.1 divided by 1 equals percent change in quantity demanded divided by 10. Got it? Now, want to cross multiply now. All right? So cross multiply the 1 to the percent change in quantity demanded. Write it down on the left-hand side of the equation. Percent change in quantity demanded on the left-hand side. And on the right-hand side, take the 0.1 in the numerator that we had, elasticity of demand, times the percent change in price, 10. 0.1 times 10. What is that equal to?
1.
1. So now write that on the right-hand side of the equal sign. So we said percent change in quantity demanded equals the price elasticity of demand times the percent change in price.
So it's 1.
Equal to 1. So now we know that we increase the prices by 10%, that everything we are going to sell, we're going to be able to get 10% on every single item that we sell. But we're only losing 1% in the quantities. And therefore, our revenue will go up, right? Because the increase in the price of the item that we sell, even though we are selling fewer items, right?
Mm-hmm.
But the reduction in the number of items we are selling is so much smaller than the price that the price effect, increase in the revenue due to higher price of the smaller number of units you're going to sell, is greater on the revenue than it is from the loss of the unit, the 1% loss of the item that you didn't sell. Got it?
Got it.
Okay. So that's how you use the information. That's my point. Use the information that is given to you to calculate. So in other words, that we figure out that the percent change in quantity demanded is equal to the elasticity, price elasticity demand times the percent change in price. And I gave you the formula to be able to actually calculate as to how that is that is achieved. So that holds for any quantity calculations, whether it's quantity demanded or quantity supplied, different elasticities. So now let's suppose that for the same situation, let's suppose that the elasticity was 2.0. Okay? Use the same example. If the price elasticity of eggs is 2.0, pretend it is soda. In fact, let's use the example of coffee, 3.3, right? If let's use a number of 3. So elasticity demand for Coke and Pepsi is 3. If the Pepsi and Coke companies decided to change their price by 10%, what will happen to the demand for Coke and Pepsi? So if the price went up by 10%, will their revenues go up or down? With the elasticity being 3.
Will it go down?
Right. Why? Because what will happen? Now argue out why that's the case. You increase the price by 10%. How much will the quantity drop by? multiply the elasticity number by the percent change in price. What does that give us? 10% times 3
0.3
equal
0.3.
Now, how do you get that?
Wait,
We are multiplying.
wait. You said 3 multiplied by 10%.
No. Or 10, remember 3%, they're percent equal. So you're multiplying the 10 and 3. You're not going to take 0.1. 10% is 10. We're using percentages, remember?
Oh, okay. So it's 30.
Right? Because the formula says percent change in quantity demanded divided by percent change in price is the definition of elasticity, right?
Yeah.
And that number is equal to 3.
Okay.
Right? If that number is 3, then if I cross it again, I use my imaginary line under the 3 of 1, right? So my ratio now looks like percent change in quantity demanded divided by percent change in price equals elasticity of 3 divided by 1, right?
Yeah.
Okay, that's the equation. So now I want to cross multiply left to right. So percent change in quantity times 1 gives me percent change in quantity on the left-hand side. Equals, now cross multiply the 10% change in the price through the elasticity of 3. So 10 times 3 is 30.
Yeah,
so the percent change in quantity demanded is now
30.
30, right? 10% change in price times the elasticity of 3.
Okay.
And 30. So because I would lose 30% in sales, that is why my revenues will go down. All right? So I hope that this demonstrates pretty dramatically that the rule is that when the price elasticity of demand is less than 1, when it is inelastic, the total revenue will increase for a change in price. When the price elasticity of demand is greater than 1, the total revenue impact is a reduction in total revenue. When the price elasticity of demand is equal to 1, there is no change. So you see, among the 3 situations here, this would be true only if the elasticity had been 0. Or I'm sorry, exactly equal to 1. 1.0, not 0.1. Right? If the elasticity was equal to 1, what would that mean? Why wouldn't the revenue change? Let's take the example. If the price was raised by 10% and the elasticity is equal to 1, what would be the change in the quantity demanded? I want you to use my formula and calculate that.
So the change in quantity
Percent change in quantity demanded, what will be that number?
would be 10.
It will be exactly 10, right? Because you said quantity demanded of whatever the quantity demanded, percent change in quantity demanded divided by 10, which is the percent change in price, is equal to 1. That's the definition of unitary elasticity. So therefore, the 1 divided by 1 on the right-hand side, and on the left-hand side, we have quantity divided by 10. We cross-multiply both sides. We get percent change in quantity demanded equal to 10 times 1, which is 10%. So a change in price of 10% results in a change in the quantity demanded of 10%. So this means that if I raise 10% prices by 10%, my quantity demanded only falls by 10%. And therefore, it's fully compensated for. That is, whatever I lose by the number of units I am losing in sales, I'm gaining by charging the 10% higher price on the item that I do sell. That's why there is no change in total revenue. So intuitively, does it make sense that when price is inelastic, when the price elasticity of demand is inelastic, revenues will increase because an increase in the price of a certain percentage will result in a lower than that percentage in the quantity demanded. And therefore, you get more from the revenue increase from the price, and it more than covers the loss that you have incurred because you lost some units that you didn't sell. When the price elastic demand is equal to 1, it simply says that if I increase the price by 10%, right, my elasticity says that the same percentage will be the result in the quantity demanded. So it will compensate for any loss that I have. All right? So higher price will make up for the lower units being sold. When the price is elastic, that is, the price elastic demand is greater than 1, that means that when I increase the price by 10%, my reduction in demand is greater than 10%, and hence the total revenue will decline. All right? So that's a very basic point and important point to remember as far as elasticity is concerned. All right? So let me switch to the now chapter 10 actually has the rational consumer questions, right? So let's take a look at let's do 9 first. 9, since we just did it last week, do I need to go back on that?
It's fine, I think.
I'd rather go back to 10 and spend the remaining time we have on the rational consumer. So give me a moment. I'm going to stop sharing this one and open the new file of chapter 10. And that will give me... Okay, here we go. All right. And we'll start sharing. And I'm going to share this one. Okay, now you can see chapter 10. Okay, yes. So let's go to the very important points to remember about chapter 10. Okay. Definition of utility and marginal utility. And then on top of it, diminishing marginal utility. That's going to be the key. That we recognize that for each additional unit being consumed, the marginal utility, that is the additional utility, is smaller than that was realized in the previous point. And therefore, we recognize that as the total satisfaction, total utility increases, but the incremental utility is declining. So the marginal utility is always going to be diminishing. Okay? If that's the case, then we recognize that the behavior of consumers is reflecting that. That is, as people consume more and more, the marginal utility will decline and they will reach a point where the maximum utility is reached, okay? And we then want to derive a principle that will say, what are the consumption possibilities, right? So in this slide, you'll see the concept of the budget constraint and the consumption possibilities. Okay, so budget constraint is a line in this graph that shows the trade-off between one and the other. In other words, egg rolls versus quantity of Cokes in this example, right? So we say that if we spend all of the money we had on one item, let's say on egg rolls, the total number of egg rolls we could purchase would be 5. If we spend it all on Cokes and none on eggs, then we can get 10 Cokes. So that between joining these 2 points gives us a budget line that says that any point along this line, the person can choose a combination of Coke and egg roll. So at point B, you can have 8 Cokes and maybe one egg roll, or a little more than one egg roll. At point D, you can have 3 egg rolls and 4 Cokes, right? You see the reason for this combination? All right, so this picture also points out that what the yellow area that's below the budget line is called the affordable or feasible region. That anything in this area, the person can choose because it is below the budget line, right? Anything beyond that is unaffordable. Anything to the right, that's not feasible. You cannot achieve that, all right? So anything along these curves would be optimal. You would be utilizing all your resources and be able to get a combination of the two, all right? Inside, if you do that, you can pick any point inside, but it will be feasible. You'll be able to get a combination of A and B, but you will not have used all of your resources. So that's why we don't consider that to be optimal, in the sense that you haven't utilized your resources. You're not on the budget line. All right, so that's a distinction to remember. Now, let's go to the optimal consumption bundle. And this is one of the fundamental points that I wanted to emphasize. What is the definition of an optimal consumption bundle? It says that we consume a number of items, not just 2. In this example, we've been talking about just 2 of them, right? Quantity of Coke and the egg rolls, right? In general, we have multiple products in our in our consumption basket. So the question is, what is the optimal consumption bundle? Given my budget, given the amount of money I have to spend on all the items I want to consume, how would I choose how much of each item I should use, okay? So this is what the consumption bundle says, that if I were to look at the utility curve of all the things that I consume, egg rolls and Cokes, right? You see both of those on the line here, right? Whatever combination of those I use, I look at the total utility curve. And I find that initially it begins to rise slowly, and then it comes to a point, because of diminishing marginal utility, because at each additional step, the additional utility is smaller and smaller. At the top of this point, where total utility is maximized, the marginal utility is now 0, right? There is no additional utility being realized from consuming 1 more unit of that item. And therefore, we have reached what we call the optimal, all right? So if that is the optimal function, optimal utility that we want to achieve, what is the rule that will get us to that point, all right? So I'm going to use this example here. You will recall this example that we use the ratio of the take a look at the price of ice cream and the utility of ice cream. So if the marginal utility of ice cream versus gum compared with the price that we pay for each is the key rule that we use. So we want to sort of use the rule that says, what is the marginal utility of gum divided by its price versus the marginal utility of ice cream divided by its price? Meaning that I want to reach a point where I pick different amounts of each item that I consume, at which point the utility I get per dollar spent is the same for the 2 items that I'm consuming. And if I'm consuming 10 items, rule is the same. All right. So we generalize that by saying that the optimal combination, if you only had two products, gum and ice cream, would be that where the marginal utility of gum divided by the price of gum is greater than the marginal utility of ice cream divided by, you would prefer gum. But if it is equal, then you prefer them equally. So to reach a point where we get to an optimal bundle of all different items, this is the rule that we use. And this actually it comes up in some of the questions you will find. The optimal consumption bundle is always where the marginal utility of item A divided by the price of item A equals the marginal utility of B divided by the price of B equals the marginal utility of the last item Z that I may consume divided by its price. In other words, the optimal consumption bundle is that at which the quantities I consume of each item are determined by the ratio of their utilities, marginal utility, to the prices of each item. In other words, the utility per dollar spent is equal for each item that I consume. Okay? So that is really the essence of what these chapters cover. Marginal analysis is being applied. And here you have marginal utility. Then we have the marginal revenue, marginal cost, and of course the elasticity. So these are the three different areas that you should review, read the chapters, do the practice questions. And I have chosen questions from all of the 4 chapters that are going to be in the test. And you'll have an opportunity to try them and try to work them out. And as I said, please take the time in your mind while you're trying to answer the questions in Canvas on a sheet of paper, work the numbers out, draw the pictures so you can have a visual image of what the thing should look like. Well, that brings us almost to the end. Let's use the last minute or two if there are any further questions.
Yes, Professor, the limit time is 2 hours, right? And then if we need a little bit more, then you can increase it?
Well, for the exam, I think 2 hours for 40 questions.
Not the big questions, like a lot of math. So we take a time to solve the problem.
Well, let's try that. But if somebody, I will be watching. If somebody needs to go beyond it, okay. I will be glad to extend it then for everybody.
Okay.
To be fair, I think everyone should get the same opportunity.
Yeah.
And if you would like to discuss it now, if you want me to give you more time, if the class wishes to do that, I can extend the time beyond the 2 hours.
Not too much, a little bit more, but the thing is, the start is 9:30, right, Professor?
The lecture will stop at 9:30. I'm going to start like 9:26, 27. I'll stop before that. At 9:30 sharp, the exam will be open, and then you'll be able to start it. And then you'll have until 11:30. But if let me hear from the class. If you wish to have more time, you can tell me now, and I can set it up so that it goes to, let's say, 2.5 hours.
Yeah, thank you, Professor. And then attempt only one, right?
No, you have 2 attempts.
Oh, okay. So
depend
of time to, if I'm not good, then I do it, but depend on time.
Yeah, and the highest you score will be the score we'll count.
Yeah.
But your second attempt has to be made within that 2 hours, right?
Yes.
Okay.
Okay.
So
There's a quick question.
Yeah.
on this utility, right?
Yes.
How do you determine what the utility is? What is that figure? How do you
Okay.
determine that?
You see, this is in as I said, we try to simplify things.
Yeah.
So the concept is the satisfaction that you get, right?
Yes.
From consuming something. And economists like to use the term, see, utility is the value of our satisfaction from
Yes.
consuming something. Well, that satisfaction is very subjective, right? But economists like to quantify things. So we have to take a number. And that is why we say that let us assume that the quantity of, if I take one, a cone of ice cream, I would get a certain number of, certain level of satisfaction measured in terms of, maybe you achieve a certain level of, if you can define an index in any kind of a way.
So in other words, so that figure is it's a given.
It's given, yeah. It is assumed. It is. Can you excuse me 1 second, please?
Sure.
Brother Usman, I'm in my class right now. I'm just about to finish. I'll call you back as soon as I finish. Thank you.
Okay, so it's an assumption given amount. So it's not, I can't calculate the utility.
No, you assume that is a certain number of units. They call it utils. It is something. Let's say that just like when surveyors ask you question, customer satisfaction surveys. I just did something yesterday for Aetna, for example, the medical group that I use, and they say at the end of your call, there'll be a survey. There'll have 5 questions on a scale of 1 to 5. Tell me how you felt. 1 is the lowest and 5 is the highest grade, right? So I've just created a scale for my level of satisfaction. So that is how economists like to quantify that. And consumer surveys are done every day. Customer satisfaction survey is done. The business satisfaction, business confidence survey is done by asking people. And if you ask a lot of people these questions, overall, we find that we get an idea, even though each individual cannot put a number, right, on that satisfaction. When we add it all up, right, on average, we'll say, if somebody said on a scale of 1 to 5, how strongly do you feel about the customer satisfaction, the customer service that you got? If you keep saying 5 every time, that means you got the highest level of satisfaction.
Gotcha. Okay.
So that's how utility is measured that way.
Okay.
Okay. And then of course, price is a known number.
Yes.
So you see, this is what economics does. Economics, as I said, simplifies the world and then uses numbers, even though human beings don't think of utility as a number of units, right? Yeah. But we have to have some kind of a quantification method. And that's what economics allows us to do. And because we can simplify things and use these numbers, we are able to draw conclusions that would be impossible otherwise. Does that answer the question?
Yes, it does. Yes, it does.
Okay, anyone else? All right, have a great week. We will see you next week. And as I said, my first part of the lecture would be just 1 hour, and we'll open the exam at 9:30.
The practice test is posted.
Oh, the practice test is open now.
All right,
so you can start using it right away.
Okay, thank you.
You're very welcome.
Take care, Professor.
All right, take care, all of it. Thank you very much. Bye-bye. I will stop sharing.